Imagine a world cloaked in darkness where sunlight struggles to penetrate. This is the realm of the submarine, a marvel of engineering that explores the hidden depths of our planet. Submarines allow us to map the ocean floor, study marine life, and unravel the secrets of our planet's past. They have played pivotal roles in exploration, warfare, and scientific discovery. Join us as we delve into the fascinating world of submarines, exploring their history, technology, and vital roles. We will uncover the secrets that allow these underwater behemoths to navigate the dark depths, unlocking a realm of wonder and discovery. The ability of a submarine to control its buoyancy is fundamental to its operation. It's all about mastering the balance between weight and displacement. Imagine a simple experiment, a small empty cup floating on water. Add pebbles and it starts to sink as its weight increases. A submarine operates similarly, using ballast tanks to control its depth. When the submarine needs to submerge, the ballast tanks are flooded with water, increasing its density. To resurface, compressed air is pumped into the ballast tanks, forcing the water out. This careful control allows the submarine to achieve neutral buoyancy, hovering at a specific depth. The dream of underwater exploration is not new. In 1620, Dutch inventor Cornelis Drebbel constructed the first navigable submarine. His vessel, crafted from wood and leather, could reportedly stay submerged for several hours. The 19th century saw significant advancements in submarine technology. In 1863, the Confederate submarine H.L. Hunley made history by sinking the USS Housatonic. The 20th century ushered in modern submarines with diesel-electric propulsion, sonar technology, and advanced hull designs. The use of nuclear reactors in submarines, pioneered in the 1950s, provided these vessels with virtually unlimited underwater endurance. Navigating the depths of the ocean presents unique challenges. Submarines operate in a world of darkness where sound travels differently and visibility is limited. Sonar, or sound navigation and ranging, is crucial for submarines. It emits sound waves and analyzes the echoes to determine the distance, size, and shape of objects in the water. Early submarines relied on human power, but diesel-electric propulsion revolutionized submarine design. Nuclear-powered submarines developed in the 1950s generate immense power, allowing them to remain submerged for months. This development transformed submarines into true submersibles capable of circumnavigating the globe. The development of nuclear propulsion was a game-changer, transforming submarines into true submersibles capable of circumnavigating the globe without surfacing. Submarines play a crucial role in naval warfare, acting as deterrents, intelligence gatherers, and guardians of the seas. Their ability to operate undetected for extended periods makes them ideal for surveillance missions. Beyond military applications, submarines are indispensable tools for scientific research and exploration. Equipped with advanced sensors, cameras, and robotic arms, they allow scientists to study the ocean floor and observe marine life. Submersibles, smaller and more maneuverable, are frequently used for deep-sea exploration. One example is the exploration of the RMS Titanic wreck in 1985. Submarines have also played a vital role in studying underwater geological formations such as hydrothermal vents. These vents may hold clues to the origins of life on Earth, and submarines allow scientists to study these extreme environments up close. Navigating the vast ocean depths presents unique challenges for submarine crews. Submarines rely on inertial navigation systems, sonar, and underwater mapping. Inertial navigation systems use gyroscopes and accelerometers to track the submarine's movements. Detailed charts of the ocean floor provide vital information about their surroundings. For communication at greater depths, submarines can deploy a buoyed antenna that trails behind them while submerged. From wooden vessels powered by oars to sophisticated nuclear-powered behemoths, submarines have come a long way. They have played pivotal roles in shaping our understanding of the oceans and pushing the boundaries of human ingenuity. The development of autonomous underwater vehicles, or AUVs, is poised to revolutionize oceanographic research. These robotic explorers can venture into environments too dangerous or remote for humans. Imagine fleets of AUVs mapping the ocean floor, monitoring marine ecosystems, or searching for valuable resources. As we strive to unlock the mysteries of our planet's final frontier, submarines will continue to be our eyes, ears, and hands in the deep. Subscribe for more to Guiding 501.